Bismillahirrahmanirrahim. For this topic, let us see some key concepts in software engineering. We'll see software process framework and their activities, basics on the software engineering practice, and some myths about software development. Right, so basically the objectives of this lesson is that to be able to explain what software engineering is, and to explain what is process framework in software engineering, to explain process adaptation, some software engineering practices, and to differentiate between software myths and facts. Okay, so let's have a look at some introduction to software engineering. Okay, now software engineering, there are some realities that we should be aware of. Okay, in any software engineering project, first of all, effort must be there, to understand the problem before a software solution is developed. So software engineering project is not something that we simply immediately write the codes, but the problem has first be understood and clear, right? So because of that, the design activities in software engineering becomes a pivotal activity. It's one of the most important activities that should be done. Okay, and the expectation is software must exhibit high quality and it should be made maintainable. Right, so these are some realities in software engineering where because of this expectation, so those who involved in software engineering project must follow proper approach or methods in developing software. So a seminal definition about software engineering refers to the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. Right? So here, when we talk about software engineering, we are talking about sound engineering principles. Okay, and in the end of the day, we are aiming to produce a reliable software and efficient software that works on real machines. Right, there is a formal definition on software engineering, okay, by IEEE. So they define software engineering as a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software, and software engineering encompasses the study of approaches as in one. So we are talking, when we are talking about software engineering, it covers sort of approaches, many approaches that would help us, to develop software according to a systematic, disciplined, and a proper measurable approach. Alright, now when we talk about software engineering, okay, it is considered as a layered technology where the bottom line is there must be a quality focus. So in any organization, the aim, in the software development is actually to achieve a high quality or good quality product. So there must be a culture, organizational culture, that leads to effective approaches to software engineering. Because if they don't have this culture, they simply develop the software just for the sake of developing, right? Without the aim of having product that is of good quality. And having the quality focus in mind, okay, it has to be based on a proper process, methods, and tools. So process, methods, and tools, these are all technologies that are required, okay, to develop software. So for example, when we talk about process, it refers to a proper framework, a framework. So we define a framework that helps us to control the projects properly, right, and establishes the context. And there must be a proper methods as well, okay, which comprise of tasks to support the processes, like for example, requirements analysis, modeling tasks and testing tasks. And of course, we need tools, Tools are needed whether automated or semi-automated tools, because they will support, they will support the methods and processes used in software engineering or software development project. Now, right, let's have a look at the process framework. Okay, so in defining process framework, there are two things here. First of all, we have to understand what are the framework activities, and then what are the sort of umbrella activities in the process framework. So under the framework activities, there should be the tasks, the work tasks. There must be the work products. There must be the milestones and deliverables, and also the quality assurance checkpoints to determine the quality level of the product. Now, with regard to the framework activities, okay, there are 5 major activities. These are the generic process framework. When it is generic, that means any process framework in software engineering have these 5 things, 5 elements, right? The first one is communication, because communication is fundamental in any software engineering project. You have to communicate with the stakeholders, with the people involved in the software development, right? And that's the basis of understanding all the requirements, from the stakeholders. And then there comes the planning. Planning is important because we need to have a proper plan, a proper like a map, so that we know our journey. For example, like how long the project gonna take, how much efforts gonna be spent, and how much money should be spent. Those plannings is important so that we know that we are not over budget, in implementing the solutions. And then there is this modeling thing. Okay, in any generic process framework, there must be a modeling activities. Why modeling is important? Because based on our communications, we have to understand and analyze the requirements. And from that analysis of requirements, we also need to design. So this involves the modeling task. Alright? And of course, there will be construction activities. This is a phase where there must be a code generation and testing activities being done. And of course, deployment activities is the final activities that should be there in a generic process framework, because this is the phase where we are deploying the software to the customer, to the user. So bear in mind that normally we don't say that it has to be started with the first activities and then move to the second and third and so on. This is not like it has to be rigid or in sequential, but actually it has to be there. This whole framework, it has to be there. And sometimes when we come to the modeling part, we might goes back to the communication activities, where there are things that we have to be clear when we do the modeling. Okay, now when we talk about process framework, there are some umbrella activities that is important to support the process framework. These are some of the umbrella activities. When it says umbrella activities, these are all the activities that basically require in order to support the process framework that we mentioned just now. Like the first one is software project tracking and control. Okay, there must be a proper project tracking, so that we know that we are going to the right direction, and we know that this project is not exceeding our budget. The project is actually fulfilling our can make use of the available resources, right? So there must be a proper tracking and monitoring and control. And there is this risk management as well, the risk management activities to support the process framework, because there is no project without risk, right? Risk is there, so we need to understand. We need to how to say that, mitigate. How do we mitigate if such risks occur? So risk is supposedly be identified earlier, so that we know how can we mitigate if that risk is occur. And then there is this software quality assurance. Okay, so this is also important, because we need to have a level of quality check, right? And technical reviews. Okay, technical reviews is also one of the important activities. Because without technical review, sometimes we overlook, because we cannot rely on merely on the testing phase. We cannot rely on the tester, to test if there are any bugs. But these technical reviews will help support reduce, any possible bugs or error that could happen in our codes. And then another important thing is measurement. Okay, measurement. So this is something that along the way, there is some measurement task that should be there. Okay, so this measurement will help us to control to manage the project properly. So we know that we can measure how much effort to do to develop such expected requirements, and then how do we measure in terms of the budget, how do we estimate the cost. So there are some level of measurement is actually needed. Okay, and then software configuration management, this is also important, okay, especially when we have to manage changes that occur in the software project. And then there is this reusability management. So it's about how do we think about developing, product that can be reused later on. So this is something difficult and complex, but if you are able to foresee what kind of components, what sort of things that we can actually reuse. So reusability management is something that is important actually to be taken care in software engineering project. And of course, work product preparation and production is also needed. Okay, so we are properly prepared, introducing the software product or services. Now, okay, with regard to this talking about software process and whatnot, there is what we call as SWE book. SWE book stands for Software Engineering Body of Knowledge. So it's a guide actually. It's a guide developed by IEEE and NSEM. It's a guide developed by software engineering professionals in industry. So they come up with this guide so that we know how do we structure the knowledge in software engineering. So actually it comprises of, if you see all these boxes, has comprises software requirements, design, construction. So these are all, I would say there are chapters, in the guide, in the SWE book that we can refer to. Okay, so it's important information that they have actually compiled. So it consists of commonly accepted practices in software engineering. So it's a very important references. It's a very important reference for people in software engineering to refer to. Okay. Now let us continue on the process adaptation. Previously, we have talked about the generic process framework and the set of umbrella activities. Now that, let's say we wanted to employ a process model, in our project, we really have to adopt the process model to suit the nature of the problem that we are solving, to suit the kind of project that we are dealing with. So it really depends. When adapting a process model, it depends, for example, on the overall flow of activities, actions, and tasks needed, and the interdependencies among them. Because some of the activities or actions or tasks maybe can be done in parallel, rather than having those things in sequential manner. All right. And the degree to which actions and tasks are defined within each framework activity. So there are a set of actions, there are a set of tasks in every framework activity, in each framework activity. But when we wanted to use a process model, it also depends. Okay, the level of actions, the set of tasks needed, the degree to which work products are identified and required, also depends. Because sometimes when we dealing with a small project or a small scale of project development, software development, we don't really need to have a thorough work products. For example, maybe simple work products are expected, and the manner which quality assurance activities are applied Okay, this is also important when we adapt a process model. To what extent, yeah, the quality assurance activities are actually expected to be carried out. The manner in which project tracking and control activities are applied. Yes, this is important when we adopt a process model. We have to see, for example, like if we are dealing with a large, complex project that that require a huge budget, for instance. Of course, we need a proper project tracking, a proper monitoring and control taken care. Unlike small project, okay. Also, the overall degree of detail and rigor with which the process is described. Yeah, again, it depends on the necessity and on the expectation, on the requirements, the degree to which the customer and other stakeholders are involved with the project. Yeah, so this is also important. So we have to see to what extent, okay, what level of stakeholders involved in the project. So let's say when we develop a project for the whole organization, then there may be many stakeholders that we have to deal with. All right, so a different level of stakeholders perhaps require different level of communications, and the level of autonomy given to the software team. Okay, autonomy here in the sense of perhaps decision making. All right, so if we give certain level of autonomy to the software team, perhaps they can do some level of decision making by themselves. And the degree to which team organization and rules are prescribed. Okay, this is also depends from one project to another project. Sometimes with a small project, normally we don't really have strict rules, need to be prescribed as compared to a huge and or a large complex project. Now, what about software engineering practice? Okay, how do we see software engineering practice with regard to the process model that we have discussed? Okay, when we talk about software engineering practice, okay, there is this set of essence of practice, that have been proposed by Polya. Okay, so Polya come out with these 4 things. The essence of practice. In every practice, it is important to first understand the problem, and then plan a solution, and then carry out the plan and examine the result for accuracy. So it looks like common sense steps. These common sense steps, nonetheless, they are actually suitable, to be used, for software engineering. Because when we look at this essence of practice, for example, understand the problem. So in software engineering, we have to do this communication analysis. This is a necessary activities, as we have seen in the generic process framework, because we need to understand the problem that we are dealing with. And then once we understand the problem, okay, once we have done the communication with the stakeholders and do the necessary analysis, we come out with a proper modeling and design. This is where we plan the solution, right? And then when we have such a design, okay, then there is this code generation happen, activities happen, and finally we do the necessary testing and the quality assurance activities, to check that we have actually delivered what we're supposed to deliver. Okay, right. Okay, this is the explanations to the essence of practice as proposed by Polya. So Polya suggested, when we are trying to understand the problem, when we wanted to employ this or to adapt this to software engineering, the first thing that we have to remember, in understanding the problem, we need to ask several questions, like, for example, who has a stake in the solution to the problem? So we need to have a clear answer to this, meaning that during the communication, we have to be clear, who are our stakeholders? Okay, what are the unknowns? Okay, for example, what data, function, features are required to properly solve the problem? Things has to be clear. And then, can the problem be compartmentalized? So is it possible to represent smaller problems that may be easier to understand? This is also something that we have to think. And whether can the problem be represented graphically? Yeah, can analysis model be created? So these are necessary when we understand the problem. So when executing the solution, we have to plan first. Yeah, planning the solution. So in planning the solution, there are a couple of questions that we can ask. For example, have you seen similar problems before? So this is important just to check, yeah, whether is there any patterns, yeah, is there any similar solutions that have been proposed previously? Yeah, is there any existing software that implements the data, functions, and features needed for this particular project? Or if there is any similar problem has been solved previously, is there any part of the solutions that can be reused or not? Right? Can we have a sub problems being defined? Can you represent a solution in a manner that leads to effective implementation? Yeah, for example, can a design model be created or not? Okay, so when carry out the plan, okay, we can ask questions like, does the solution conform to the plan or not? Whether the source code traceable to the design model or not? Whether each part of the solution provably correct or not, right? So we have to check whether has the design and code been reviewed, yeah, or better have correctness proof have been applied to algorithm or not. So and when we wanted to examine the results, yeah, questions like, is it possible to test each component part of the solutions? Yeah, has we done the necessary or reasonable testing? And does the solution produce results conform to the data, function, and features expected? Right, so these are the things that we have to check, yeah, against the deliverables. Now, on top of the POLIA's essence of practice, there are a set of general principles suggested by David Hooker. So David Hooker suggested 7 general principles for software engineering. First, we have to know the reason it all exists. Why do we need this software? Yeah, it has to be clear. And keep it simple. Yeah, so we don't need to necessarily design something that looks complex or what, as long as it is something that is adequate, yeah, to solve the problem. Keep on maintaining the vision. Yeah, we need to have the clear vision on what we are producing. Number 4, what you produce, others will consume. This is important mindset, because we have to remember that whatever that we are doing, whatever that we are working and delivering one day, other people will consume. So we have to remember that someone else will maintain this software. So how gonna, it looks like if we design it properly, so someone else will do the, maintenance work easily. And then be open to the future, because change are expected. And change are always expected in software projects. So we have to open to the future and plan ahead for reuse. If this is important. If we could or able to do the necessary planning if the certain things can be reused or not for future project. And the 7 general principle is think. This is very basic and sometimes overlooked. So sometimes we really have to take time to think whether what we do is something that is necessary or correct. Sometimes we are not sure whether we are doing the right thing, but at least we put time to think, and most likely that we are hopefully doing the right thing. Okay, the last thing is on the software myths. Yeah, some myths about software development. Myths here refers to beliefs that might be misleading. So there are a couple of aspects, yeah, when we talk about software myths, from management perspective, from customers perspective, from practitioners perspective. For example, from management perspective, the belief is that there are available standards and procedures. Okay, so there's no need to train staff. Well, that's not true. Okay, the situation is that we have to train the staff, although there are available standards and processes, because sometimes they are not maybe clear enough to the staff. And this is interesting, the second point, adding more staff to lead software project. This is a myth, okay? When we add more staff, because the project is already delayed, so we thought that when we add more staff, it could salvage the project. Eventually, it makes the project longer. It makes the project even delayed, because why? We have to train the staff who just join in. So that's not well, a wise solution actually, to add more staff when we are actually late. And then when we outsource the project, yeah, it does not mean that we don't need to monitor. Okay, from customers' perspective, yes, sometimes they thought that certain things can be, fill in details later. Actually, we need to have things very clear from the beginning, so that we know that we are coming out with the proper requirement specification, for example, right? And the customer always think that we can change if you want. Yes, of course, they isn't always expected, that they may be require some changes, but however, those things have to be properly managed. And from practitioners' perspective, yes, they have the thinking that once they're done with the job, it is done. Okay, but actually, the reality is that 60 or 80% of the effort must, spent on the maintenance and updates. So it is not that once we complete the source code, that's it. Okay, and there are more others myths from practitioners' point of view. For example, they said that, oh, I can only test once the code is completed. No, this is not right. This is not right belief. Actually, the code has to be tested from the beginning to discover error from the early stage. Okay. Yep. What else? How it all started? Well, every software project is triggered by some business needs, of course. The need to correct a defect in an existing application, maybe when we want to develop a software because we know that there are some defects, or there is a need to adapt a legacy system to a changing business environment. When there are legacy systems that has to be customized, there is something that we have to do to make sure that the system is still usable. And then perhaps we need to extend the functions and features of the existing application. So we need to have maybe embark with a new project. And there are new set of features or functions expected from the customers. And the need to create a new product, services, or system. So therefore, of course, when there is such a need, we have to actually discuss about it. What sort of new product, services, or system expected or required by stakeholders. I think that's all for this topic. Thank you very much. So in summary, hopefully that you are aware of this, software engineering process framework.